in this particular lecture, what we're going to do, this is important one. In this particular lecture, initially we started with the resistance, microscopic form of Ohm's law, whatever we done in the previous. But this is mainly and focused on two topics, which is drift velocity, relation between drift velocity, the current and electric field, and mobility and relation between the mobility in the electric field, and the number of questions on that particular two topics, not more than that. Okay, so this is the symbol of your resistance. What is resistance? Now you tell me according to your language, in your language, not bookish language, because in the previous lecture I told you what is resistance, and this is symbol of resistance, not symbol. This is resistance in general. That is how look like resistance in laboratory. Resistance in labs. Okay, when you go in any particular college, controls the flow of current. Okay, anyone else? Instead that is resistance in labs. And from your CBSE, that is removed the color coding, but we in this particular chapter we going to give you the color coding also. Color coding of resistance. BB Roy have Great Britain wife, something look like this. In the next lecture maybe you're going to get. Okay, so that is color coding. This is brown, black, red. First one is going to be for first significant figure, second for second, third for power, and the fourth, you see, it is not visible, but that is gold. That is for tolerance. Tolerance is error in this. So on the color basis, we can say how much is the resistance of that particular small look like object or small look like instrument or symbol. So the hindrance faced by the electrons. Okay, anyone else? What is resistance? That is the question in general. Color coding of resistance in next lecture. We going to learn in next lecture. We are going to learn also. Tell me anyone, beta. Basic thing. See, the basic thing is a difficult thing. Obstruction offered to flow of current is resistance. Okay, actually mix up, or you can say the mix kind of answer is going to be given, and the resistance is exactly you can define in your own language, like the force, or not force, the resistance is defined as the obsession, or not obsession, I'm saying the resistance is defined as the opposition force applied, or opposition or oppose applied by any particular material whenever the flow of electron, whenever the flow of charge particle is going to be in any particular material. Okay, so don't need to worry about the definition, because understanding is main. So what is drift force? So that is new something for you guys. So what a drift force is, the electrons move or drift inside a conductor due to drift force. What is in this general stands for? First of all, we know there is a random motion of electron. Okay, there is random motion of electron. Which color I choose? Yeah, we have random motion, basically electrons in conductor, of electrons in conductor. That we already asked, but still, as we know, in any particular conductor, in any particular material, when the number of charge particle is high, or basically electrons, so they are moving randomly. So when they are moving randomly, until unless we don't apply potential difference or this battery or cell, so they are not moved in the particular direction until unless we don't apply the potential battery. So the moment we apply, due to this positive and negative, the electrons tends to flow in this direction, or the positive charge particle tends to flow in the opposite negative direction. And this is flow of electron, and this is hole. So flow of holes and is going to be in opposite direction, flow of electrons is going to be the positive direction, and in the opposite direction of this electron we see that current is going from positive to negative. So the electrons moves or drift inside a conductor due to drift force. What is the meaning of this? The moment we apply this particular voltage or battery, okay, so they are drifting, they are, you can say, attracting towards, because this is negative charge particle, we all know electron is negative charge particle, so they are drift, or you can say attracted towards the positive cell, or you can say positive terminal of a battery or a cell, and this drift force or this particular force with which they are attracting towards the positive terminal of a battery is known as drift force. Is this clear, everyone? Is this clear what is drift force? The electrons move or drift inside a conductor due to drift force, or more explanatory, you can write the force with which electrons drifting or attracting towards positive terminal of a battery. Terminal Positive terminal of a battery or a cell, in general battery, is known as drift force. Is this clear, everyone? So what is a drift force? The force or with which the electrons move towards the positive terminal of a battery. This is the positive terminal of a battery, so we can see that. Okay. And random motion of electrons, what it is in general? Random motion of electrons, if I am going to draw, suppose this is your conductor, so in this particular conductor, this is your electron randomly moving in any particular direction. This is known as your random motion of electron. In the absence of what? In the absence of any particular battery or cell. So removing this, you can understand in this way. Clear, everyone? This is your random motion of electron, or random motion of electrons in conductor. Everyone clear what is a drift force or what is random motion of electrons? Just type yes if it is clear, so everyone. Okay. And Hari Mahesh, we are working on your this particular, whatever the suggestion points you raise in the PTM, like syllabus whole or academic planner for full year, and notice and notification for the homework or class assessment also to your parents. So that is all about drift force. Moving ahead, recall electricity is like a water hose, because in the previous class I told you current is general definition, and then current is what? Continuous motion of any particular thing, for example water particle, for example air particle in same sense, whenever charge particle moving continuously in any particular medium due to the potential difference, that particular thing is known as electric current. So electricity is like a water hose, voltage which gives the pressure in any particular electric motor, you can understand, or in a particular pipe. Current is like a, you can say, size of this particular hose, or resistance is going to be sand. Means as we know, this V equals to I, V directly proportional to I, and V equals to IR. In the previous class we learned this. This is Ohm's law. So this R is in general what? The proportionality constant and the resistance which is going to be offered by any particular material. So in same sense we can understand, take an analogy. For example, if you throw a water, if the water flow is going to be in any particular pipe system, drainage system, so whatever the pebbles, whatever the sand is going to be in that particular water system, so that particular sand is going to oppose the water flow. In the same sense, that resistance is taken as a sand or a pebble whenever there is a water flow in any particular drainage system, in any particular city or anywhere. Is this clear, everyone? So we can make an analogy like this also. The resistance is nothing but the opposition, or you can say given by the particular material, given by the conductor, given by the semiconductor, any particular medium, whenever there is a flow of electron. For example, like this. Clear everyone? Is this clear beta everyone? Okay, and current, we everyone know current is nothing but continuous flow of particles. Continuous flow of particles. It can be air particle, it can be what? It can be air particle, it can be water particle, it can be charge particle. Is current. Okay, so that is in general current, and for any given the current, voltage and resistance, Ohm law is defined in this way. Okay, that is very easy, not to worry about. Moving ahead, this is microscopic form of law, or you also can write it down as a vector form of Ohm's law, and I think everyone know about it, vector form of Ohm's law. In the previous class, we define how we can get it. J equals to sigma E, where J is current density. J, you can write I by A. This is your current density. Here A is a area vector, because I we know the scalar quantity, so that is why it is a vector quantity. Okay, and E is beta electric field. We know that, you can understand V by L also, and then sigma, which is conductivity, which is 1 by rho, resistivity. Okay, so Simon or ohm per centimeter inverse, we can define that, and this is again comes from this equals to. Okay, just put the value of R in the previous class, as I told you, rho L by A, and rearranging the every term, we can get this. I'm not going to derive this again, but I just let you know for the people who are not in the previous class how we can go about it. Okay, so just put R equals to rho L by A, and V equals to this E into L, and then I equals to this simple J, I by A can be converted into J. So automatically you get this relation number A, or the relation number 1. Clear everyone? And who are not getting how we can prove that, or how we get this particular relation, so please go and watch the previous lecture. Clear everyone? In the previous lecture, in the detailed manner, I derived this also. Clear beta everyone? If you have any particular question, query, anyone, so you can ask me right now. Okay, and if don't, so we can go ahead. Dharmeshwar, Shrutika, Jyotsna Prabhakar, Kaila Netra, and everyone. Kritika, Hari Mahesh. Okay, no doubt. Good. Then moving ahead, this is now we're going to learn in this particular class. This is the beginning kind of thing. Till now we just revising what we were already done in the previous class, and kind of a teaser or a trailer. So that is we're going to do. What is drift velocity? Let's understand the definition wise, and then we're going to understand the physics concept behind that also. So the name is drift velocity because the electrons drifts in the opposite direction of the velocity, opposite direction of the electric field at a low velocity and at high thermal velocity between two collisions. Now what they are saying, see, until unless we don't apply any particular potential difference to the this particular conductor, this is conductor, so they are randomly moving like this. Okay, they are randomly moving like this, or when they are randomly moving like this, so automatically they're going to collide with each other, and they also collide with the ions also, because there is not only electrons in that, but we have positive charge particle also. Clear? So there are two kind of velocity we're going to see. First, whenever we apply any particular electric field, so due to this electric field, the electrons the electrons going to drift, due to this positive negative scenario, one thing, and they automatically are in random motion, beta, so sorry, they are automatically in random motion, so they collide with each other, and when the collision is going to be again and again and again and again, so due to the collision there is a high thermal, because you can observe that when you hit some particular thing, So that particular energy is going to be somehow converted, a little bit converted into thermal energy. Okay, thermal means they are going to heat up. So when they collide with themselves, electron will collide with ions. So this is that particular word they write it down at high thermal velocities between two collisions. So first thing is clear. There are collision also. There is drift velocity due to this positive negative also. Okay. If we don't apply this particular battery, still we have a drift velocity. Is this clear, everyone? If any particular viva question or if any particular theory question is arises like this, did we have drift velocity in the absence of this particular potential? Yes, we have. Clear, beta, everyone? Clear now? Okay. The second thing, drift velocity is defined as the, now this is the proper definition, proper kind of definition. What is drift velocity? Obviously for board examination that is going to be help you out, but for JEE that is not, because there is no this definition going to be work out. Drift velocity is defined as the average velocity with which the free electrons get drifted towards the positive end of the conductor under the influence. Now this is the word, under the influence of an external electric field. But in the absence of electric field also, due to this collision thermal agitation or thermal velocity, we have a little bit drift velocity. Or properly, the average velocity with which free electrons get drifted towards this is defined as a drift velocity due to the presence of external electric field. Clear, everyone? Is this clear, beta? Okay. So now moving ahead, drift velocity. This is just a little data kind of thing. The drift velocity of electrons is in the order of 10 to the power -4, but the actual range is 10 to the power -3 to 10 to the power -5 meter per second. Okay, that is the actual range of a drift velocity. The external electric field applied to the conductor set up if V is the potential difference applied across the ends of a conductor length. What is this? Suppose this is your conductor, and in this particular conductor, the moment you apply any particular sort of battery, okay, this is your V and this is your length of L. So we know this relation E equals to V by L. Okay, so due to this particular potential difference, we have electric field. This is the simple, they written down there. Now, derivation of drift velocity. Okay, so this is important. Start noting down by your own, because that is going to help in your board examination as well as in understanding as well as in question framing also. Because starting from this, they can ask anything. Okay, so that is the derivation. Each free electron in the conductor experience a force which is electrostatic force. This is your electrostatic force. Because of electric field, the moment we apply electric field or a potential, so because of this electric field, this is the electrostatic force on each particular electron minus QE. Okay, this is your electrostatic force QE. Here Q is minus E, charge on an electron, as simple as that. The acceleration of each electron is A equals to force by M, as we know, simple. Force equals to mass into acceleration. So from this particular relation, acceleration is F by M, and we have force here equals to minus EE. Minus E is the charge on an electron, E is the electric field. Therefore, this is your going to be acceleration, where M is mass of electron. What is the mass of electron? Anyone? Tell me. What is the mass? You know that? Anyone, beta? Because if you don't know even the order, so that is, you don't understand what is the power of this, because that is going to be very high. Tell me, anyone, what is the order of mass of an electron? Write it down or tell me, because then after you realize how much speedily or how much fast they are moving? Anyone better? That is very easy. Why you hesitate to write this just number? Mass of an electron. What is the number? You tell me, Harimesh. Mass of an electron. And just please everyone turn on your camera also. Everyone. And I just forget. Yeah. Is it that much hard? Seriously? No, 1.6. Harimesh, that is charge. 9.01 into 10 to the power minus 3, 31. Mass of an electron. How this is going to be help you out? 9.1 or 31, I guess, if I'm not wrong. But that is the order. Okay. And mass of proton is 10 to the power minus 27. This is 9.1. Yeah. Okay. So that is your order. Now you can see if I'm going to divide with 1 unit of electric field with the charge. So that is charge of an electron is 1.6 into 10 to the power minus 19. That is 19, that is 31. Order of almost how much? 12. So your acceleration is going to be 10 to the power 12 positive meter per second square. How much, how fast they are moving. And that is why the moment you just click the button or just your fan is going to be start, your bulb is going to be glow. If someone asks this question, this is very basic, very general, like how this particular current is going to be very fast. So this is the reason. Clear everyone? Clear na? Because just putting the number or order, the acceleration of electron is somewhere 10 to the power 12 meter per second square. How fast is this? Now you can understand. Okay. So that is why deliberately I asked this data. Because the moment you understand the data, you get the answer automatically. Okay. So now simply at any instant of time, the velocity acquired by the electron having thermal velocity u1 will be v1 equals to u1 plus a tau 1 or at. This is your first equation of motion first. Similarly, velocity acquired by the n number of electron or other electron, this is for 1, this is for 2, this is for 3 going to be, this is for n. Okay. Instead of 2, this is 3, 3 and 3. This tau is relaxation time. And that is separate question they ask on the what is relaxation time. Okay. So the next page is similar. So let's skip this. Now the average velocity of all the free electrons in the conductor under the effect of external electric field is drift velocity Vd of the electrons. So in the previous page, what we get, V1 equals to U1 plus A tau 1. Okay. In similar way, V2 equals to U2 plus A tau 2 dot Vn equals to Un plus A tau n. Now you tell me, what do you understand by this tau? What do you understand by this U2 or U1 or Un? Because V1, V2, V3 is velocity of each particular electron which is drifting towards the positive terminal. Where come from? From where this U1 and tau 1 comes? Tell me anyone. And if you don't know, then why don't you ask? Tell me. This U1 is what it is in general. Obviously, tau 1 we're going to explain. Tau 1. Okay. Anyone know this or not? Or should I explain? I'm asking to you, beta. Anyone know this or not? Anyone? There are not n number of people. I don't know why I get the habitual of saying n. There are 14 students. Anyone know this? If no, say let me know also. So we can quickly recap the things. Okay. So beta, this U1 is the thermal velocity due to this collision of electrons and in between ion, and this tau is the relaxation time. What is relaxation time? In general, relaxation time is the time duration in between the two successive collision of electrons. Suppose this is your electrons. Okay. These are your electrons, and these are your holes, positive, not holes you can say, but ions you can say. So obviously they are randomly moving. So when they are randomly moving, so they collide with each other. So this u1 is the velocity of random moving electrons, first of all, and this tau is, what is this tau? The relaxation time, or the time between. Okay, basically that is we're going to explain on the next page, but still tau is relaxation time, or how we can define time duration, time taken in between, that is between, in between the successive collision of, in between the successive collision of electrons and ions. Ions here is positive charge particle. Okay, and this let me write here, this mu is, why should I write mu? This mu is, u is thermal velocity. Thermal velocity of random moving electrons, of random. In the previous class KTG, there is a kinetic due to the there is a kinetic energy due to thermal. Ke equals to 3 by 2 kT, if I am not wrong. K is Boltzmann constant, and this is kinetic energy due to this temperature thing. So this is why it is written in this way, thermal velocity of random moving electron. Thermal means the moment there is 1 Kelvin even. Okay. So due to this 1 Kelvin temperature, the electrons, the charged particle starts moving, and obviously when any particular object is in the moving state, so that particular attained kinetic energy. Okay, so this u is thermal velocity of random random moving electrons. Clear everyone? What this tau is, what this mu is, and there is a relation also, but we're going to focus here first and then to find the relation. Is this clear what tau and u is? Everyone? Okay, so as we know, this is we define in this way the average velocity of all the free electrons in the conductor under the effect of external field. Okay, is drift velocity. So Vd is this V1 plus V2 plus V3 plus V4 plus Vn divided by n, because this is average velocity. And we put the value of V1, V2, V3. So U1 plus A tau 1 plus U2 plus A tau 2 and plus UN plus A tau n, and A is minus EE upon ME. Okay, if you are confused what A here is, so that is your drift velocity. Clear? Now one thing, this summation of u1 plus u2 plus un plus n going to be 0. Why so? And where tau is tau 1 plus tau 2 plus tau 3, and this is your average relaxation time. This u1 plus u2 plus u3 plus dot 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 plus un divided by n is going to be 0. Now anyone tell me why? You tell me why. Because since starting we understand this, what is this u1. Now you know what this u1, u2, u3. So anyone please tell me why this is 0, the average. Tell me, this is very common sense or basic. Why this is 0? Okay, I'll give you a hint. This U1, U2, U3 is random velocity of thermal electrons. Okay, so obviously they collide with each other, and when they collide with each other, so what happens? Now guess and tell. Not even guess. Now I give you the proper hint. Okay, tell me why it is zero. Anyone, beta? I mean the average of this U1, U2, U3, U4, U4, U5, UN divided by N is zero. Why? This is the question. And if you don't know, so please write it down. Sir, we don't. Go ahead. Muthu, you tell me why it is zero. Why are you so silent? Are you there? Yeah, beta, go ahead. Hello? Hello? Am I audible? Or anyone else can tell me? Or they can write it also. Why it is zero? Very basic. You tell me, Jyotsna. You look so serious today. What happened? I mean, are your parents are not happy with the PTM reports or something like this? Okay, how many of you get scolded after the PTM? Honestly, tell me. Then I'm going to tell you. How I was thinking. Okay. How many? This is question. Another question other than this physics. How many of you get scolded after the PTM? Specifically after my PTM. I took 8 or 9 students at that day, and I was like, I'm done. I'm done. I'm done. Lots of speaking, and after your PTM also I speak at least 1.5 hours. How many of you? Harimesh, you? I hope and I believe you get scolded. Why don't you do this homework? Why is so much pending homework? Zero thing everywhere. Zero, zero, zero. Isn't it? No? Seriously? Oh my goodness. Okay, that is very basic, very easy. Suppose you are 10 students in a class, and I just lock the door of a class. Okay. So even if you are moving or running here and there, the net velocity is going to be zero. Why? Because you are not coming out of the class. Okay. Means the moment you collide with each other, due to the collision, after n number of times, after again and again, your velocity is going to be lower down, and when your velocity is going to be lower down, the average velocity is going to be zero. Simple. Simple again example. Take a, you can say, marbles in any particular closed box. Do that. Shake like this. Okay, and just put it down. After a minute or a two, the average velocity at that particular marble shaking thing is going to be at rest again. That is the basic thing. Clear, everyone? What is happening here? Because they are randomly moving, so just pick 1, 2, 3. 1, 2, 3. This particular 3 is going to be collide with the 4. This 2 is going to be collide with the 1 or 3. So after the collision, they are not more, you can say, moving fast, but they are going to stop after a certain time. So this average velocity, thermal velocity, is going to be zero. Clear, everyone? Is this clear with everyone? Got it? So putting equation number 2, this is your equation number 2 and equation number 1. Equation number 1 is this Vd equals to dot 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 and summation and so and so. So Vd equals to A tau in simple, where A equals to minus E by M, and the order here by, okay, value is the order of 10 to the power minus 14. This is misprint because we find velocity. So that is minus 4 meter per second. And that is Vd equals to A tau, because Vd is what? Okay. In general, Vd is V1 plus V2 plus V3 plus dot 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 Vn divided by N, where Un is going to be 0. So then Vd becomes a tau, where this tau is nothing but tau 1 plus tau 2 plus tau 3 plus this, okay, yeah, tau n divided by n. So this is your drift velocity. In the moment we put the time, this is my average drift speed. Speed and velocity, what is the difference? Okay, don't ask that question. The minus sign kept, it is negative in the direction, and it is negative in what direction? Negative in the direction of electric field. You can see here, this is your electric field in the from right hand side to the left hand side. In this way your electric field is going to be, and in this way your drift velocity is going to be. Okay, is this clear everyone? So that is why this negative sign comes automatically generally, and that negative sign, this explains that. So just putting the value of a, which is minus E by m, we get the drift velocity relation, and that is important one. Right now we are doing that, so you remember this, you're going to solve the question on that also. But believe me, when the whole book, or not whole book, when whole two books, not two classes books, I mean 11th class and 12th class is going to be, so you just forget this small term, even that concept, what is drift velocity, then you find difficulty to solve this. Okay, and then there is a relation going to be also we created, and we find it not created. This is average speed. So when they told you to find average drift speed, so you just forget the negative sign, because this is how we're going to find the speed from the velocity. We just are curious to get the magnitude, not the direction. This negative sign gives us the direction in the reverse of electric field, but the magnitude, when we are just need to find the magnitude, or we are interested in only magnitude, so we just skip that negative sign, and that is your average drift speed. Clear everyone? Is this clear with everyone? Okay, so that is your this thing. Okay, moving ahead. Derivation of drift velocity with mu j and something. Now there is another. Okay, let me check. What is this? I equals to NEVD or something relation like this. Okay, this is the relation between your drift velocity and mobility. So this is another relation, important one. So till now everything is clear. What is drift velocity? Drift velocity is nothing but the average velocity of the electrons of each particular electrons whenever we apply electric field. As simple as that. We have the this thermal velocity also in the absence of electric field, but that is going to be 0. Clear now? So moving ahead, this is due to another relation. Due to the frequent collision that electrons have, their drift velocity is going to be small if the cross section is constant. That is I mu j is for a given cross section area. The greater the current density, the larger will be the current. In the presence of an exceptionally large number of free electrons in a conductor, a tiny amount of drift velocity produces a large amount of electric current. What is the meaning of saying that? Means even if we have very small, or 10 to the power minus 4 or 10 to the power minus 5 drift velocity, but the number of electrons is Avogadro number. What is Avogadro number? Anyone please tell me? Avogadro number. What it is? What it is with Avogadro number? I just remember the power 6.023 into 10 to the power 23. Is this correct? I'm always confused in this and H. Is this correct with everyone or anyone? Why should I write it down? Why? Where from? 1 mole. Yeah, I think so. So in 1 mole, in 1 molecule, we have that much number of electrons. Now you think if we have number of particles in 1 mole, exactly. So if we have 10 moles, 20 moles or 100 moles, okay, so how much number of electrons we have? So even if we have 10 to the power minus 6 or minus 10 drift velocity, so multiply with this much number and you get the very high speed or very high velocity. That is, this high speed, high velocity is going to generate the current. Why so? Because current is nothing but the flow of electron, the flow of charge particles. So the high amount of charge, high amount of electric current is going to be generated even with very, very small drift velocity. That is the meaning of saying this sentence line. In the presence of exceptionally large number of free electrons in a conductor, because we know in a conductor the number of electrons is going to be 10 to the power 8 or so and so. Okay, resistivity is going to be in this minus, so the Avogadro number and the conductivity is going to be higher. So a tiny amount of drift velocity produces a large amount of electric current. So the electric bulb glows immediately when the switch is turned on, because current transmission is practically as fast as light and involves electromagnetic process. In the presence of electric field, the path of electrons between successive collisions are curved, and in the absence of an electric field, the path of electrons between successive collisions is a straight line. Okay. Free electrons density in a metal is N, which is Na into D by A. Na is the Avogadro number, D is the area, or you can say this density, and divided by A. Okay, this small n, we're going to use that. In this way, if this is your area, this much is your area, so this is your density, or this is your distance. So in this particular distance, N is number of Avogadro, D is distance divided by area. Is this clear, everyone? This is just our definition and the actual meaning what we're going to see. Is this clear, everyone? Okay. So moving ahead, now relaxation time, you can see that in a proper definition kind. The time interval between two successive collision of electrons with the positive ions in the metallic lattice, that is going to be defined what is the metallic lattice in the chemistry or in higher classes in physics as well. Metallic lattice is defined as a relaxation time. But one simple thing I can give you, what is the meaning of metallic lattice. Every particular solid or any particular structure is made up like something look like this. There are three kind of lattice: simple, cubic, body centered, and face centered. Okay. In this way we have arranged the electrons. If I'm not wrong, this is simple cubic. This is known as your lattice in general. Okay, so now you can see that when this particular electron is going to intersect with this electron or positive ion maybe, so the time interval between two successive collision of electrons with the positive ions in the metallic lattice is defined as relaxation time. So beta tau is mean free path divided by RMS velocity of electron. This is symbol is wrong. You can use this. This is your mean free path. Okay, so just remove this, and this is your mean free path divided by what the sentence we have. I forget VRMS. So this is your mean free path. This is VRMS. So tau in general, this also. This is mean free path, and this is VRMS. I hope and I believe everyone gone through the previous classes lecture, specifically length class, so you know what is VRMS, what is V average, what is VMP, most probable. Okay, is this clear now, everyone? So tau is universally proportional to VRMS. So when VRMS increases, consequently tau is decreases, and vice versa. Means if the root mean square velocity of electrons or charged particle is going to be increased, so this tau is going to be decreased. This is mean free path. Mean free path means this. And in KTG we have a relation 1 by lambda d something and so mean free path. So from there you can get the relation of mean free path also. But important thing is this relation. They ask question on that. like tau, which is relaxation time, is how direct dependent on mean free path. Is this directly or is this inversely? Okay, is this clear, everyone? Or should I give you mean free path relation also? Data wise mean free path. I'm confused in formulas, so please forgive me about it. Mean free path NA by, okay, this is your RT upon root pi d square NAP, and now P is pressure if I'm not wrong, and mean free path is 1 by pi d square NB, that is also. So there are n number of formulas you can go at, but one of the related from the KTG, this mean free path is, okay, let me give it to you, RT upon root pi d square, RT upon root 2 pi d square NAP. This P is pressure, R is universal gas constant, T is temperature, root 2 you know those, know that, pi is constant, D is this distance, or the simple D is what we get from the conductor, or you can say symmetry. From the symmetry we write D na, this from the previous, this is your D. Okay, so that is your mean free path and that is your VRMS. So now you can find the relation. This is tau, time. Okay, this is what it is, relaxation time, tau, and this is temperature. Two are different things. Temperature, P pressure, R is universal gas constant, and A is Avogadro number. Is this clear, everyone? And A is Avogadro number. Okay, that is how we can get the so many interrelated relation, and from any particular combined thing they ask you a question in JEE, means you don't need, I mean, some initially you are going to confuse which particular formula we are going to use. So there is a one important relation in this way. So even from that particular relation you can find the VD, which is simply A tau, and A is minus EE by M. So many interlinked relations for tau, for VD, for mean free path, for so many things. Okay, till now everything is clear. This is your lattice. If no one is understood by simple cubic. Okay, moving ahead. Till now we done. This is your another learn concept, mobility. So what is mobility? Electron mobility is defined as the drift velocity per unit electric field. Simply mobility mu is Vd by E, or you can say the drift velocity per unit electric field is defined as mobility. Okay, is this clear, everyone? Basically the general meaning of mobility is how your electron is mobile. Mobile means how much that particular charge particle, not only electron, how much that charge particle in any particular material, conductor, semiconductor, non-conductor, or you can say insulator, how much it have the mobile property, the moving characteristics whenever we apply electric field. Or you can say if we apply unit electric field, in general that is the meaning. If we apply unit electric field, what is that, volt per meter? Okay, so how is going to be, because that is dependent on the, is dependent on the mass of electron. 3, what you ask, beta Dharmeshwar, 0.333. Do you know, I mean, do you want to ask some question? Okay, okay, it's okay. So that is mobility. In general the meaning of sorry, in general the meaning of this mobility for, okay, let me write it down. For unit electric field, for unit electric field E, electric field E, how much is the drift velocity? How much is the drift velocity of electrons, or you can say charge particle of electrons for any particular medium conductor, for any particular material. Material is the correct. Why so? Because then from the previous lecture, Vd equals to A tau. What is Vd? Even I am confused. Vd is what, beta? Where we have the relation minus E by tau. So mu is minus E tau by m, and tau is this relation. As simple as that. Okay. Yeah. So we have Vd minus E tau by m, and from there mu is going to be Vd by E, which is minus E tau by m. So mu, which is mobility, directly proportional to tau, and we have another relation with tau. Okay, so there are so many relations, but the main thing is this. Is this clear, beta, everyone? Mu, which is electron mobility, is defined as drift velocity per unit electric field. Its unit is meter square per volt into second. Therefore, Ohm's law can be explained in terms of drift velocity as Vd equals to mu E. Okay, this is your another form of Ohm's law. You can write in this way also, because the moment we expand this, we get the same relation. Is this clear, everyone? In terms of, they can ask you directly, write the Ohm's law in terms of mobility and drift velocity. So that is your important relation. You need to write it down, and from this direct relation, there are numericals they are going to be formed also. Clear? See, the basic thing, you need to understand the definition and how we're going to use from one particular formula to another particular formula. Just simple. See, mu is nothing, means saying that what if, suppose you are doing any experiment, or you just changing the scenario, you just changing the assumptions. So that is the same way we are doing right now. What if the electric field is going to be 1? So for that, we just given a particular new quantity which is known as mobility. What is mobility? The drift velocity for particular electrons, for particular charge particles in any particular material wherever the electric field is 1. What is electric field? The moment we applied 1 unit potential for a single unit of length of conductor, that is electric field is 1 by 1. So there are n number of formulas going to be generated. Clear? Because the moment I put E equals to V by L, so this Vd equals to mu V by L also. So it's you need to understand what particular given quantity, what particular quantity is given to you guys in that particular numerical question, and which thing is going to be they ask. So using bunch of relationships, you need to solve the question, and how you can do that? When you do the practice. As simple as that. Till now everything is clear, everyone? That is nothing new, but the drift velocity for 1 unit for electric field, 1 volt per meter, or we can say for unit electric field. Clear, beta, everyone? That is material. Okay. So moving ahead, these quantities, you can say SI unit is meter per second. It is also measured in meter square per volt into second. The magnitude of charge drift velocity per unit electric field applied is specified as the mobility of charge carrier responsible for current. So mu, which is drift velocity divided by electric field, which is mu equals to Vd by E, mu equals to E tau by m by E. So this is your important relation which we are going to directly use, mobility of electrons. Okay. mobility of electron mu equals to E tau by m. So what particular question they ask in general from this relation, if instead of mass of electron we're going to use the charged particle proton, how your mobility is going to be changed? Simple. Means instead of electronic mass, instead of electron, if we consider this charged particle is any particular ion or positive charge, or you can say alpha particle, so how your mu is going to be changed? And SI unit of mobility is meter square per second per volt, or meter per second Newton per coulomb, per Newton into coulomb. So many quantities, but the simple relation. Is this clear, everyone? Okay. So let's give a break for 5 minutes, and then we're going to do the important relationship this. Okay, meanwhile you can read this relation between current and drift velocity. In the same way, we're going to find the important relationship between current and drift velocity. Sorry, this mobility. Okay, so just read. Yeah, you can also go for a drink, for washroom, for any particular thing. After that, we're going to find the important relation, and then we're going to do the question. There is a 5 to 10 minutes break. You guys are free to do something also. Something means take a break. Hello, hello, hello. Am I audible? Hello, 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 beta. Hello, am I audible? Am I visible? Yes. Okay. So, okay, let's finish this and do the questions. So that is very easy relation, but important one once again. So starting from the very basic, as we know, current I is defined as Q by T, right? So this is your current. Let length of a wire L, area of cross section A, and number of electrons per unit volume they want to write. This is N, and drift velocity D. Okay, let me draw this particular diagram. This is my favorite diagram uh, in this particular teaching thing. Just give me a minute. So suppose okay, this is your suppose a conductor. In this we have electrons. The moment I apply this particular battery, so okay, this is your positive negative terminal, positive negative. So obviously electrons are tends to move in this direction, opposite the direction of electric field, and electric field is going to be in this direction, and current is also be going to in this direction, I. So suppose this is length of L conductor. Okay, I equals to Q by T. Q is charge. L is length of a wire of cross section. Suppose this is the macroscopic, or you can say you see this particular wire with the help of a microscope. So you can see, visualize this thing. Now A is the area of cross section. This is your area, and N, which is small n, number of charge per unit volume. This N is number of charge per unit volume. Clear? And now you can understand Vd, simple. Velocity is length upon time. So suppose this is your length, and this particular electron take times from this particular end to this particular end in any wire. So this is your drift velocity in simple words. Is this clear, everyone? Just forget about this whole Vd relation and everything, average and so and so. In simple words, what is velocity? Displacement upon time, distance upon time, length upon time. Is this clear, everyone? Tell me, is this clear till now? Are you there? Anyone? Is this clear, beta? Okay. Okay, so this is your, in simple words, Vd equals to this L by T, and time, which is L by Vd. Now volume of conductor, which is area into length. This is simple. If N is the number of density of electrons, that is the number of free electrons per unit of the conductor, then the total number of electrons in the conductor, or you can say total number of charge, which is area into L into N. Why this so? Because N is what? Number of charge per unit volume. So if I want to find the total charge, you can say number of charge particles. So what I'm going to do, this N into volume, okay, and this small n, and volume is area into length. So this is your relation till now. Everything clear? Whatever written in on this page, just let me know. This is very easy. Quickly, this is clear, everyone? Is this clear, beta? I hope and I believe this is going to be okay. So now the total charge of on all free electrons in a conductor Q, which is number of electron into charge of electron. So simply this okay. So this total charge, sometimes I'm doing silly things. Total charge, which is Q, is Ne. Okay. E is electronic charge. This is from the quantization of charge from the first class. N is number of charge per unit volume. So charge, number of electrons into, sir, can you show the previous slide for a minute? Why not? You don't need to write, okay, just write it down whatever you want to, but everything is going to be saved as a PDF. Okay, beta? Is this clear, Jyotsna? Okay, so this is total charge, which is Q equals to Ne. So charge, number of electrons into charge of each electron, and Q equals to A into L equals to Ne, because charge on a particular electrons we have A, L, N, and then E. So equation B, this is your total charge we're going to get from the previous chapter, because charge for one electron, we get charge for one electron, charge for electrons, or you can say total electrons. Charge for electrons is N, into A into L. Simply N into volume. So just total charge equals to number of electrons. Okay, this is not charge, this is number of electrons. Number of, let me erase this also. I mean total number of electrons in wire, that is this thing, N into A into L. So the charge is Q equals to Ne, where N is total number of electrons, A into L into N into E. So as a result of this, field, the free electrons in the conductor will drift to the left, as indicated in the diagram below. As you can see, free electrons is going to be drift in the positive side, and current is going to be the opposite side. So putting equation A and B in equation 1. So first of all, I equals to Q by T. Okay, we know this simple relation I, current. This is your equation number 1, I equals to Q by T, where T we have L upon Vd, and this Q from the equation number B we have A into L into, or simply I'm going to write A L N E. So just using that, I equals to A L N E and divided by L into Vd. So L going to be cancelled out. This L is going to be cancelled out, and I equals to NeVd. This is the famous relation. This is the famous formula which is going to be used everywhere. This is your important relation in between the current or this drift velocity. This is I equals to N E A, I equals to N E A Vd, right? Vd is the drift velocity. Now, more importantly, we know that current density, which is I by A. So divide both the side in the above equation with area. So beta current density is nothing but NeVd. Okay, so this is how we can get this. The average velocity gained by the free electron of the conductor, which the electrons get drift under the influence of electric field, is given as Id equals to I by A and E. Okay, from that you can get drift velocity Vd equals to I by A I divided by NEA, where I divided by A is J. So you can get this, and putting to the value of Vd, which is E tau by M in equation number 5. In this equation you can get the I from here also. So there are so many number of relations with I, with J, with Vd. You need to just focus on the simple things. I equals to Q by T, and Q equals to volume into number of charged particle, total number of electrons, which is small n, which is number of electrons per unit volume, which is A into L into N into E, and then time T equals to L by Vd, where Vd is drift velocity, L is the length. So doing that, we can get this relation. So as you can see, I equals to NeVd, J equals to I by A, putting equation M, or you can say putting equation 7 in the above equation. So just formulation from one equation to another equation, we can do that. Nothing more than that. Because therefore J equals to NeVd. So I already write it down, where J is the density of current, A is the area of cross section, number of electrons per unit volume is N, drift velocity is Vd, E is charge. Okay, so the important formula you can get simply this is one, I equals to N E A Vd, first thing. Then I equals to NeVd, I by A, which is current density J. Okay, simply just write J, that is NeVd. If we write the formula of Vd, which is minus E tau by M, putting here and in J also. Okay, so then we can rearrange this I, which is NeA E This is D, not E. Just give me a minute. Okay. So N E A E tau by M. So putting this N E square A E tau by M. Now in a similar way, J equals to I upon A. So just divide the above equation with A. N E square A, sorry, not A is not going to become E tau by M. So these are the important relationship for each particular thing, and they starting from what? I equals to Q upon T, as simple as that. Is this clear with everyone? See, there are n number of formulas, I know this. Right now you are going to be confused also, but the moment you understand, okay, let's start from the beginning, and then you are going to be understand in a very crystal clear way. We start from, not here, a little bit, yeah. So first of all, we know this I equals to Q by T, simple thing, charge per unit volume, charge upon time for any particular length of wire L, area of cross section A, and N, which is small n, number of electrons per unit volume. This is number of electrons per unit volume, and drift velocity Vd, right? So n, small n, number of charge instead of, you can say, electrons, because that is going to be more clear in your head. Number of electrons, because here number of charge particle is electrons. So number of small n is number of electrons per unit volume. Simply we know that velocity is length upon time. So drift velocity for this particular length, for this particular time duration to pass this one charge particle or n number of charge particle from this particular point A to particular point B is Vd, which is L by T. So from here we can get T, which is L upon Vd. This is your equation number A. Okay. Or you can write this is your equation number A. Now we know the volume of conductor is, or volume of any particular symmetric thing, area into length. So electron, or you can say total number of electrons is A into L into N, which is this number of electrons, simply N into volume. Moving ahead, total charge on all free electrons in the conductor, Q equals to Ne. So using this we get the equation number B. This is your equation number B. Okay. Now putting this equation number A and B in equation number 1. This is your equation number 1, I equals to Q by T, or equation number A. Or you can write here, it is written down 1, but because this is the new learned concept, so we can write equation number A for easy, to make this easy. So just put this A and B as it is written over here. Put equation A, putting equation A and B in equation 1. Equation 1 is this, I equals to Q by T. Equation A is this, A is this, and B is this. That's why I separately write it down here. So rearranging the terms, I equals to NEAVD, you're going to get it. This is the famous relation. So this is your equation number 5. You can write it down, or because we start from the equation number 1 for this new learn concept, so we can write it down this as our equation number 2. So this is your famous equation number 2, which is I equals to NEAVD. Then we know Vd equals to I by A and E. We know I by A is J. So J equals to NEVD. We can put the value of Vd also. And just as simple, we put this as equation number 3. So there are n number of equations you can generate, but the concept is easy. Is this clear, everyone? So this all is just rearrangement of formulas and everything, nothing more than that. You just need to focus on this. I equals to NEVD, J current density, I by A NEVD, Vd which is drift velocity, that is this, and this is again the formula using this and that. So nothing you can say confusing, but I know for you guys that is going to be a little bit. Is this clear, everyone? We just rearranging the formulas from the simple formulas, nothing more than we do. Tell me, is this clear everyone or not? If you have any question, doubt, query, so you can ask me right now, because the moment we going on and on in this particular chapter, that is going to be a little bit difficult or hard also. Clear everyone? I equals C. I equals to NAVD, J equals to I by A, which is NEVD, VD equals to E tau by M. Then this formula, just these three formula, and mu, which is mobility, VD by E. These formulas, if you doing so many questions and going to write it down and going to derive this relationship, whatever I am doing right now, you automatically get the habitual like me. Is this clear everyone? No doubts, no doubts, no doubts. Good. Okay, so this is your assisted practice, easy one. Drift velocity of electrons when 1.5 ampere of electron flow in a copper wire of cross-sectional area. If V, okay, is the if the electron density of a copper is this, the value of V in mm per second is close to. Everything is given, current is given, area is given. This is N because this is, you can automatically see number of electrons per unit volume. So you need to find V, which is drift velocity, clearly mentioned. So tell me what is the answer. I'm not going to elaborate. I equals to NAVD. That simple formula you're going to use. VD. Instead of VD, you just need to find V. Or you can write VD. Use this formula. But the thing, something hidden in this, you need to find mm per second. So you get something which is 10 to the power minus 3 meter per second. Okay, that is enough hint I given to you guys. Everything is given after this. So put into the formula and find the correct answer. So all this and tell me the answer. Then you discuss this class assessment also. There you find some good question. This is good one also. But obviously right now you are discussing, we are discussing. So just you need to put the formula and find the answer. What is the answer? Tell me. See, that much time is not required for this, at least 2 to 3 minutes enough. Okay. So tell me which is the correct answer. Tell me beta. A, B, C, D. Which one is correct option? Are you guys doing? What happened, Hari Mahesh? Okay, 1 minute. And please, everyone, turn on your camera. How many times I need to say this? If you are not turning on, so how can I see you like Hari Mahesh? So how can I ask you, like you facing some problem or something like this? Everyone, instead of me, you need to do this. Sai beta, did you take this particular session or maximum number of sessions from phone? B. Solving and 2. Okay. Some of the answer is B. So might be the multiple of B 2. So let's see. I think it is D. 0.02 because 0.02 into 10 to the power minus 3 meter per second. So the correct answer is 3. Okay. Easy one. Okay, moving ahead. Now you need to find this. When 5-volt potential difference is applied across a wire of length this, the drift speed of electron is this. If the electron density of the wire is this, the resistivity of the material is close to. This question is good. Tell me. Okay, tell me which particular formula we are going to use. See, when 5-volt difference is applied, so whenever this kind of question you face, so just write it down what is given and then think in your mind like what we have. We have potential difference, okay, 5-volt, right? And then we have length also 0.1 meter. So from that we can find E V by L first thing, but don't find in the first way. Then VD we have, which is 2.5 into 10 to the power minus 4 meter per second. Then what we have, electron density, which is n, small n, number of electron per unit volume. 8 into 10 to the power, what? 8 into the 10 to the power. Option C, sir. Oh wow, nice, meter per cube. Now with this V equals to IR, simply I equals to NAVD. We have N, we don't have A. Okay, so how we can get A, or what we need to find? Resistivity. Put V equals to I rho L by A. Now I guess we have everything. V by L is E, I by A is J, but we don't have J. Okay, so let's see how we can do that, because sometimes I am confused. I equals to NEVD, V by R equals to NEVD. Okay, NEVD, or V equals to rho L by A, putting everything into the, okay, rho is V, voltage, NELVD. Just rearranging the terms, and yes, the correct option is C. Okay, this is I equals to NEAVD, and V by R is I equals to NEAVD, and put the value of R, which is V by rho L by A. So V into A divided by rho into L equals to NEAVD. So A cancel each out, and then what we need to find? Rho. So resistivity is nothing but V upon NELVD. So in this way you can see V is potential voltage here. So in this way, just by rearranging the terms, whatever we have, we can get it, and then we get the, and then we put the values and we get the answer automatically. Is this clear, beta? So this row is 1.6 into 10 to the power minus 5 ohm meter. Clear, everyone? How you can get the option C? Is this clear, beta? See, this is, everything is given, and you just need to rearrange this particular formulas. Okay, so yes, the option number C is correct. Okay, moving ahead. So this is the summary of this particular class. Now quickly go on this particular test, and there are questions on that. Try that, and if you don't, if you find any particular difficult thing, so let me know. So major important things we cover in this particular: drift force, drift velocity, mobility, And these four are very, very important. Not only for boards, or you can say for both the things. For boards as well, boards as well as JEE means. Okay. Is this clear, everyone?